everybody, this is Mr. Munson. We are in Unit 8, Quadrilaterals. We're going to be in Section 8.2, Concept 2, and we're looking at the characteristics of special parallelograms. And so in 8.1, we started learning about what parallelograms are. This is a great illustration in this picture of a parallelogram. It's a building that I found online. I think it's pretty cool. Anyway, let's go ahead and get started. Okay, let's start off with just kind of a review, a reminder, whatever you want to call it, what a parallelogram is. So a parallelogram is a four-sided quadrilateral. Of course, it's kind of repetitive, but it has a pair of parallel sides. Now remember, we use these arrow-looking things to show that sides are parallel. Okay, so we have opposite sides here that are parallel. That's by definition what a parallelogram is. Okay, opposite sides are parallel. No other way of saying it is this is a four-sided figure and it has two pair of parallel sides. Okay, two pair. Now, not every quadrilateral has opposite sides that are congruent, but once a figure has opposite sides that are parallel, then what we find out is that the sides automatically become congruent. So that's characteristic of every parallelogram out in the world. Okay, so once you know it's a parallelogram, opposite sides are congruent. Now keep in mind, this is a shortcut, or this is a concept about how you're going to write equations. You're just going to write that these two pieces are equal to each other, and that will help you solve for an x or a y or something. Now, one of the things that, or some of the things that come at us from a parallelogram is that some things happen with the angles that are not true for every quadrilateral. If it's a parallelogram, what we find out is that the opposite sides, not the opposite sides, but the opposite angles are congruent. Okay, so we have that as opposite angles are congruent. That's one of the characteristics of a parallelogram. As you can see, these two angles are opposite and they are also congruent. Okay, another thing that happens is that when we look at consecutive angles, these are two consecutive angles. The reason they're consecutive is because they share a side. Those two angles share this side here. That makes them consecutive. This green one and this green one here are not consecutive because there's no sides in common. Okay, so what we find is that these consecutive angles, and here's another pair of consecutive angles, they're right next door to each other. Consecutive angles are supplementary. So again, keep in mind, when I tell you that angles are congruent, all this stuff has come undone. When I tell you that angles are congruent, that's an indication of what kind of equation I'm going to write. If I tell you consecutive interior angles are supplementary, then when you go to write a relationship between these two, you should say the green one plus the blue one equals 180 degrees, and you just simply solve for it. Okay? All right. So the last kind of focus we want to look at is diagonals. Okay, the diagonals of a parallelogram are the diagonals are bisectors of each other. Okay, so the green one is some length and the blue one is some length, and what we find in regular parallelograms is they're not usually the same length. You can tell this one's shorter than the green one. That makes sense because it's starting to kind of, the shape itself is leaning over, making B and D a little closer than A and B are, or A and C. As this thing, if this was a parallelogram that could move, as I push it further and further to the right and make it lean over more, the diagonal B and D should be collapsing and getting smaller as we go. So anyway, what we find out is that in a parallelogram, the diagonals bisect each other. And the way we would mark that is that these two things would be congruent to each other, and these two things are congruent to each other. Okay, so we can simply mark that. If the green, if this was 5, then we would know this one was 5, and so on. Okay, the whole thing, of course, would be 10. So we're going to be just kind of focusing in on this category of problems or shapes in this video. We'll go and look at the other ones later on. So we've just reminded ourselves what a parallelogram is. That's an 8.1 subject matter. Okay, you're welcome to go and watch 8.1 video if you want to catch up on that. Okay, so what's going to happen is we're going to just start looking at these special parallelograms. Okay, so in the world of parallelograms, there's some that have some special characteristics, which will make it a rhombus, and the other ones make it a rectangle. And then what we'll find out is that the parallelograms that have both those features, a rhombus and a rectangle, will also become a square. Okay? Now, each time we move from being a parallelogram to a square or parallelogram to a rhombus or so on, it always keeps the characteristics of the shape above it. So what we, this is easy to understand is that like every square is a quadrilateral because it came from that lineage, right? All right, so let's take a look at a rhombus. A rhombus is a parallelogram, but what makes it unique is that it's got four congruent sides. Okay, that's the big feature of a rhombus. So if I know it's a parallelogram and four sides are congruent, I know it's called a rhombus instead of just any old parallelogram. Now, as soon as we take a parallelogram and make it into a rhombus, given it four sides, some things happen to the things inside. Now, nothing really happens too much with the angles. Um, just in there, they're still supplementary and opposite angles are congruent. But something does happen to the angles when interacting with the diagonals. So let's take a look at the diagonals. Now, a couple of the features of the diagonals is that, first of all, the diagonals are perpendicular. So if I don't tell you that they're perpendicular, which I won't, you can automatically mark the diagonals in a rhombus perpendicular. Now, that should be a clue to you how we're going to go back to chapter 9 and use Pythagorean theorem, our special triangles, and our trig functions to maybe find some lengths inside the rhombus or around the rhombus. Okay? Now, the other thing is the diagonals become angle bisectors. So what we find out is that this angle right here, let me change my color here, this angle right here and this angle right here end up being congruent. So if the whole angle, let's say, was 110, each of the smaller ones become 55. Now, opposite angles are congruent, so therefore their bisections are congruent. And we're going to mark these congruent. So that's some stuff that comes from the diagonals. As soon as we take a parallelogram, put four sides on it that are the same, we start getting angle bisectors and perpendicular diagonals. Let's move on. All right, next up is rectangles. Let's go ahead and make this a little bigger. Okay, rectangles. And so again, it's quadrilateral, parallelogram. We add to that four right angles. As soon as we do that, we have ourselves a rectangle. Now let's take a look at what's going on in the inside that are new features that come from just giving it the four right angles. Now, of course, in the world of angles, the rectangles, becomes four right angles, of course. So I'm not going to tell you anything about that's happening with the angles up there. What's kind of cool is stuff that's going on with the diagonals. So what we find out with the rectangles, the diagonals become congruent. Okay, this thing's no longer leaning over like a parallelogram does. It's standing straight up, and it straightens up and makes the diagonals congruent. So the red diagonal and the green diagonal are congruent. So, if I had some measures on there, you should be able to set those things equal to each other. Okay. Now, since it's a rhombus, we know that they're also bisecting each other. So this piece would be congruent to this piece. Now, since the diagonals are congruent, if I looked at this piece being 5 and this piece being 5, the whole thing is 10. That would tell me this whole thing is 10. But then again, since the diagonals are bisecting each other, I can mark these with the exact same congruent marks as the other ones because they get bisected just the same way and they're the same length. Okay? All right. And now we find ourselves as being a square. So what do we get? We get, well, it's quadrilateral, four sides. It's a parallelogram, but it's the two features that come from being a rectangle. So it has four right angles, and it's the features that come from being a rhombus. There's no new features that come with this that are different from the ones that are in the category of rectangle and the ones of rhombus. In other words, the diagonals, they're congruent to each other. That's a rectangle issue, right? That comes from rectangles. We also know that there's four right angles because it's a rectangle. In addition to that, we know that these diagonal pieces are going to be congruent to each other. So if I see that and I figure it's a square. Now, one interesting thing that does come, certainly those diagonals are angle bisectors, but since they're 90 degrees from a rectangle, we see that each side becomes 45. That's going to be true for the opposite angles as well as these angles that are up here. So what I would do if I was you is I would realize, let me just add from the rhombus that we have diagonals or rectangles, or diagonals that are perpendicular. And so what you should realize when you see these 45s is, uh-oh, this is going to be a special triangles problem, right? And so this is one of the reasons why chapter 8, this chapter that we're in, comes after chapter 7, because we're going to just keep on dealing with the trig, special triangles, and the trig, special triangles, and the Pythagorean theorem from now until the end of the year. And so you really need to understand those things. All right, let's see if we can just kind of put this all in perspective, okay? So we start with quadrilaterals, right? So with quadrilaterals, we end up with these categories of things. So we have 4 sides. That's basically, that 4 sides is the thing that really sets it off from every other polygon out there. It's not a 5-sided figure, it's 4-sided. That's what makes it a quadrilateral. And so as we go through these little areas, I want you to understand that the arrow points to the main characteristic that sets it aside from anything above it in this category, okay? So quadrilateral, 4 sides, sum of the interior angles, 360 degrees. Under the world of parallelograms, I sometimes go to the car wash, and the car wash will say, do you want the general car wash? And then it'll say the next step up, the bonus car wash, and it'll say everything that's in the general car wash, but this more, okay? And so this is very similar to that. So we have a parallelogram, so it's definitely a quadrilateral because it falls in that species of polygons, okay? So the main characteristic that sets a polygon into motion to being a polygon is that it has a pair of parallel sides, 2 pair of parallel sides. But with that comes some additional characteristics. Opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, and diagonals bisect each other. Next up. All right, so next up we have a rhombus. So rhombus, because it falls under the category of a parallelogram, it has all the features, all these features of a parallelogram, right? I'm just not going to list them again. But it has some new features that start off with the fact that it has 4 congruent sides, okay? In addition to that, because of that, the diagonals become angle bisectors, and the diagonals are perpendicular. All right. Next up, we have rectangles. Rectangles are a parallelogram, but the thing we add to these special kind of parallelograms is that it has 4 right angles. And because of that, the diagonals become congruent, okay? So that's a feature of that. Which brings us to a square. So a square is just simply a rhombus and a rectangle with all those special characteristics. End of story. All right, so go ahead and draw your line and write your summary. Let's go ahead and go to the do it problems. Remember, you need to show all your work. Many students are starting to just write it too quickly that I can pay attention to or be able to follow what you're doing. And so you need to slow down, make sure that you're writing this so it's legible. I'll just send it back to you with very little points if I can't read it or if it just looks too messy. So make sure that you're circling your answers, you're showing your work neat and all that stuff. So here we go. Let's scroll through the problems and make sure you can see them. Here we go. Refer back to your characteristics for each of these shapes and use that to help you write equations. Okay, there you have it. We'll see you next class with this finished and complete.